in the video and what we learned about Ivan Pavlov was the fact that he had a pretty extensive career and was somebody who's pretty well versed in a number of areas. Physiology, dealing with the human digestive tract, eventually taking that and what he found by accident in those areas and using it for the area of classical conditioning and behaviorism. All right. And so after discovering classical conditioning, Pavlov was going to then spend the rest of his life expanding his ideas. And so he came up with some extensions to classical conditioning that you'll see right here. All right. Acquisition, extinction, spontaneous recovery, generalization, discrimination, and then higher order conditioning, each of which we'll address right now. So acquisition is going to be that first phase, or the preliminary phase of learning itself. This is when we first start to see the organism connect the events together in its mind. And so it goes from something that is an unconditioned stimulus to a conditioned stimulus. So all that this would have been, when we think in context of Ivan Pavlov and his dogs, was that this was the time that the dogs figured out that when they heard the bell, food was coming. That connection was being made. You're acquiring, at this point, the association. So, for example, many of you have seen the movie Jaws. All right, first few times that you see that, you don't think a whole lot about the music in the background. Suddenly, a shark pops up, and you realize that every time you hear dun 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 dun, shark is about to come. All right, you make that association. Once you make that realization between the music and the presentation of the shark, that's acquisition. Key here: timing matters in acquisition. Timing matters. For example, if Ivan Pavlov were to have rung the bell and then not presented the food to the dogs for another 12 to 15 minutes, would not have had nearly as strong of an effect on them as if you rang the bell and presented it within seconds. So that acquisition time is certainly going to be affected by time itself. The conditioned stimulus should come before the unconditioned stimulus, but they need to be very, very close together. And the further apart they are, the less strong that connection is going to be. The next one we're going to talk about is extinction. And so what this simply means is we're talking about the withdrawing of a conditioned response. This is something that's going to occur when you stop pairing the unconditioned stimulus and the neutral stimulus together, and time then passes. So as we look here, eventually Pavlov's dogs would stop salivating to the sound of the bell if they weren't being presented with the food following that. Eventually that bell would no longer have the same effect on them. So if we go back here, if you watch Jaws enough times with the sound muted, eventually just hearing the theme song won't produce that same sense of anxiety or fear knowing that a shark is about to appear. All right. So that's the idea of extinction. Now, a lot of people wonder, is extinction permanent? And the kind of the quote that you see down here, not only if you're a dinosaur. All right. The fact of the matter is that extinction does not all the time last forever. Spontaneous recovery is going to be kind of the answer to that. And so when we talk about spontaneous recovery, this extension simply means that there's a reoccurrence of a conditioned response after a rest period following extinction. Now, here's the key. You have to connect the conditioned stimulus with the neutral stimulus again in order for this to reappear. There has to have that happen, all right? So, for example, had Pavlov stopped ringing the bell and presenting the food, again, the bell would not have had the same reaction to it. However, if there is some sort of connection between the two again, over a period of time, let's say that it was spaced out for a long period of time, and you saw him ring the bell and then present the food, and suddenly the salivation started happening again, it can. This is spontaneous recovery, where it comes back kind of without warning. Here's one that you can kind of think of. The idea of songs. I know that radio today kills songs because they play them so frequently. They throw them on. There's probably about 6 or 7 that they just go through over and over and over again. The first 20 times you hear the song is pretty cool, all right? But by about the 25th, within about 2 days, you're pretty tired of the song, all right? So as we look at that, that was one that happened. You think about Wrecking Ball, Miley Cyrus, all right? You hear it on the radio, it's a pretty cool song, a little catchy song. It doesn't matter who you are, you hear it, it kind of sticks in your head. But you hear that 5 million times, eventually you're going to grow to dislike it and eventually not pay attention to it. However, if you were to hear that with your kid riding in the car 15, 20 years later, you would go, oh, I remember this song, and I loved it when it used to come out, all right? That is kind of that spontaneous recovery, the feelings returning based upon that, and hearing that again. Generalization. This is the next one, okay? This is when stimuli similar to the neutral stimulus bring forth similar responses as the neutral stimulus. So as you look here, this is usually going to happen, though, in less intelligent animals. Keep that in mind. It doesn't work for all the species of animals. For example, we're going back to that cat Greta. My cat Greta is conditioned to come running if she hears her canned food open. She also comes running when I open a soda can sometimes. She's made that generalization between the popping sound of the cat food with the popping sound of the soda. Not really discriminating or hearing the difference with the little fizz within that. She just hears the popping sound, comes running between those. So that's generalization. That happened with little Albert when he started fearing the white Santa Claus beard, the other furry animals. He generalized those together as them being the same thing. Discrimination. Discrimination. When an organism doesn't respond to a similar stimuli as the neutral stimulus. This is going to be the opposite of that. Here's something else that you want to make sure you understand. A lot of us have heard the term discrimination. You're going to hear it again in social psychology. These are the terms that mean the same thing, but in different contexts mean something very, very different. All right. So what we're talking about here is this. Usually, this is going to happen to animals that have higher levels of intelligence, and this is again the opposite of generalization. You've been conditioned, and this is very similar to somebody who was talking to me a second ago about this. I think it was you guys. This is very similar to yours, all right? You've been conditioned through school to leave when the bell rings, all right? If I rang my own personal bell in front of class, none of you would leave, all right? You just look at me, all right? Why? Because you have the ability as intelligent individuals, kind of higher level intelligence, to discriminate that from the school bell, all right? Although some of you who really want to get out of here don't make that discrimination and bolt out the door. If Greta displayed higher levels of intelligence, she wouldn't get excited from the soda can opening at all. Higher order conditioning, something else that we want to talk about. So after classical conditioning has successfully been established, the pairing of the second neutral stimulus with the previously conditioned stimulus can have the same effect. This again is what we know as higher order conditioning. Sometimes we call it second order conditioning. The thing to understand is that one typically gives a weaker response, but it still gives a similar response. So after Pavlov conditioned his dog to salivate at the sound of a bell, he could then pair the bell with a whistle. All right, bell, then whistle, presentation of food. After he's already established the reaction using just the bell. Bring that in later, all right? And so when that happens, you can pair those together, and the dog would salivate at the whistle as well, probably not as strong as the bell itself, but they still could. So that is higher order conditioning that we would see. Now, the role of the cognitive process. This was mentioned in the video as well, but it's important to note, and this is why we tie learning with cognition as well here, because they're closely linked. Now, does classical conditioning work as well on humans as it does in animals? The answer, probably most obviously here, is no. All right, it does not, because of our cognition and our intelligence. For example, the idea of alcoholism. All right, somebody's an alcoholic. They want to try to cure themselves of that. All right, so if we looked at this, somebody might have the idea in mind that they might put some sort of a nauseating drug in the alcohol. If they drink the alcohol, they make the association of alcohol with nausea, leave it alone. Do you think that that's actually going to happen? In a human being? Probably not. They're probably going to say, yeah, I'm not going to drink that one, I'll go find something else, okay? That is the fact that we have that higher order cognition that we're able to do that. So experience, knowledge are going to prevent something like this from being effective. People are too smart for that a lot of times. So classical conditioning, a lot of times does not work on human beings. Very good for animals a lot of times and training that we see with that, but the higher order intelligence limits it a lot of times when it's associated with humans. Biological predisposition is something else that's important to note. All right. Sometimes that which we are trying to condition into an individual happens more easily because you're biologically predisposed in order to do that. All right. And by that we simply mean this: those things which we need in order to survive, those behaviors we need in order to survive, are going to be more easily conditioned than those that are not. All right. So an animal's capacity for conditioning is going to be restrained by biology. Certain species are predisposed to learn particular associations that enhance their survival. A person we want to know about here of note is John Garcia. All right, this is a name that's found in your textbook. You might be one of the people in blue. I can't remember if that's the case. but he actually researched the effects of radiation on rats. In particular, their consumption of water and the link between that, all right? And so, kind of what he said was this: if we classically condition a rat to associate radiation with water, would it condition the radiation quickest to a taste, a sight, or a sound? The case that we found here was taste, all right? The fact that rats depend greatly on their sense of taste to survive in the world was something that allowed them to be conditioned more easily in those sorts of things. And so, as we see here, many species of animals utilize taste in order to realize if something is poisonous or not. And so that tells them to not drink, eat, whatever the case may be. And so, if you are trying to classically condition somebody to something, those things that they're biologically kind of necessary for them in order to survive are certainly going to be behaviors that are going to be conditioned more readily as a result of that. All right. So we can put that to the side right now. And if you would flip for me, please, to the section in your study guide that deals with the advanced classical conditioning.